Morning students, today we are going to start a new chapter by name partial fractions. In lower classes you have learned numbers, especially the integers and the rational numbers. In rational numbers we have again the proper fraction, improper fraction and the addition of several fractions into a single fraction. The present topic deals with the decomposing or resolving or reducing or splitting or expressing a larger fraction as sum of simpler fractions, especially for polynomial fractions rather than the number fractions. So the concept of decomposition of a fraction into partial fractions is useful in the differentiation, integration, summing up of infinite series, etc. So what is meant by a polynomial function? So an expression of the form f of x is equals to a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus etc. an, where a0, a1, a2, etc. an are said to be coefficients which are real numbers. a0 not equals to 0 is called a polynomial in x, where n is said to be the degree. Degree is nothing but the highest power or exponent of this polynomial. So here the degree is n. So if f of x and g of x are two polynomials with g of x not equals to 0, then f of x by g of x is called a rational fraction or a rational function, or simply be called the fraction. Example, so 2x cube minus 3x square plus 2x plus 1 is one example for a polynomial. Here the degree being 3. It is called the cubic polynomial. Likewise, x power 4 minus 1, this is a biquadratic polynomial with degree 4. Now, log of x square plus 2x plus 1 with the base e, this is not a polynomial. And x square plus 2x plus sin x equals to 0 is also not a polynomial. And so is the case with the x square plus root x plus 1 equals to 0, because for anything to be a polynomial, the power or the exponent, the highest power should be a non-negative integer. N is a non-negative integer. It will be a positive number or even 0 also, because so 2 is also a polynomial, because 2 can be written as 2 into x power 0. So here this is also a polynomial, but n should not be a rational number. So like x square, root x is x power 1 by 2. So therefore this is not a polynomial. Now, proper fraction. A fraction f of x by g of x, where degree of f of x is less than that of degree of g of x. Degree of numerator is less than that of degree of denominator, then that fraction is said to be a proper fraction. That is, examples, 2x cube minus 3x square plus 2x plus 1 by x power 4 minus 1. So here the highest power of x is 3. So 3 is the degree. Here 4 is the degree. So here 3 is less than 4. So degree of f of x is less than degree of g of x. And 1 by x power 4 x square minus 1 otherwise. So 1 can be written as x power 0. So 0 in the numerator, 2 in the denominator. So 0 is less than 2. And x minus 2 by x square x cube minus 3x plus 2. So this is of the form f of x by g of x, where g of x is not equals to 0. So this is a polynomial and this is also a polynomial in x. So here x power 1. So degree is 1 here. Here x power 3. Degree is 3 here. So 1 is less than 3. These are all the examples of the proper fractions. Now, improper fraction. If f of x, g of x, where degree of f of x is greater than that of degree of g of x, then that fraction is said to be improper fraction. So, the examples for which is x cube by x square minus 1. So here degree of a numerator is 3, which is greater than 2. So degree of f of x is greater than degree of g of x. Therefore, this is one example for improper fraction. And so x square by x minus 1 into x minus 2. Here also, this is x square, this is x into x square. So degree of a numerator and denominator is the same, is equals to. Therefore, this is also the improper fraction. Division algorithm. Division algorithm. This is a property of natural numbers, is also applicable for this polynomial fractions. So, if f of x, g of x are two polynomial, then there exists q of x, r of x, such that f of x is equals to g of x into q of x plus r of x, where r of x is equals to 0, or degree of r of x is less than degree of g of x. The chapter of partial fractions is just the reverse process of this following process. So 3 by 2x minus 1 minus 1 by x minus 2 is equals to 3 into x minus 2 plus into minus 1 into 2x minus 1 by 2x minus 1 into x minus 2. So 3x minus 3 2s are 6 minus 2x plus 1 by 2x minus 1 into x minus 2. So 3x minus 2x is x minus 5 by 2x minus 1 into x minus 2. So in partial fractions, we will be doing the opposite process. So x minus 5 by 2x minus 1 into x minus 2 going to be expressed as 3 by 2x minus 1 plus minus 1 by x minus 2. So the sum of two proper fractions is also the proper fraction again, because x power 1 here, the degree of numerator is 1 and the degree of denominator is x into x square, degree is 2 here. So the sum of two proper fractions is also the proper fraction. So here x minus 5 by 2x minus 1 into x minus 2 is equals to 3 by 2x minus 1 minus 1 by x minus 2. So this process is known as decomposition of the partial fractions, and these two are said to be the partial proper fractions. So in this chapter we will be learning the methods of resolving the given fraction into sum of two or more partial fractions. Type 1. If f of x by g of x is a proper fraction and g of x contains non-repeated linear factors, if ax plus b is a linear factor of g of x, then a by ax plus b is its corresponding partial fraction. Where a has to be determined. So if you take an example, 1 by 2x minus 1 into x minus 2. First of all, this is of the form f of x by g of x, where f of x, degree of the numerator 1 can be written as 1 into x power 0. So 0 is the degree of numerator and 2x into x, 2x square. So 2 is the degree of the denominator. Degree of numerator is less than that of degree of denominator. So this is of the form ax plus b. 2x plus minus 1. So a is equals to 2, b equals to minus 1. So of this form. So for each linear factor, there corresponds to a by ax plus b. There corresponds to a partial fraction of the form a by ax plus b. Here, a by 2x minus 1 plus. So this is also a linear factor. Both are non-repeated. So non-repeated in the sense x minus 2 whole power 1. So it is not repeated. Had it been x minus 2 whole square, x minus 2 into x minus 2, it is repeated twice. So it is said to be a repeated linear factor. Here non-repeated. So x minus 2, the corresponding partial fraction of this x minus 2 is b by x minus 2, where a and b ought to be evaluated. This is type 2. If f of x by g of x is a proper fraction and g of x contains repeated factor of ax plus b whole power n, that is ax plus b is called a linear factor repeated n times, and the corresponding partial fractions will be of this form. For example, so x minus 1 by x minus 1 whole square into x minus 4 whole square into x minus 3 whole square or whole cube. So this is clearly of the form p of the form proper fraction, p of proper fraction x power 1 degree. Here this is x square x cube x power 5 all together. So here x minus 4 is a repeated linear factor, repeated twice. So since it is repeated twice, there will be two constants. For each x minus 4, there will be a corresponding partial fraction of the form a by x minus 4. This is b by x minus 4 whole square. So here x minus 3 is a repeated linear factor, repeated thrice. So therefore 3 constants will be introduced. C by x minus 3, d by x minus 3 whole square and e by x minus 3 whole cube. So in this way we will find. So based on the concept that we have discussed so far, so let us start the first problem from the exercise 7a. 2x plus 3 by x plus 1 into x minus 3. First of all, this is a fraction. F of x by g of x, where f of x and g of x are two polynomial functions. And the degree of numerator is x power 1. So degree of denominator is x power 2. Degree of f of x is less than degree of g of x. And the denominator contains two non-repeated linear factors. So type 1. So for every non-repeated linear factor of the denominator g of x, there corresponds to a partial fraction of the form a by ax plus b. So this is a by x plus 1 plus this is b by x minus 3, where a and b are to be determined. So this is x plus 1 into x minus 3. So a into x minus 3 plus b into x plus 1. This is equals to 2x plus 3 by x plus 1 into x minus 3. Both are cancelled. So this is 2x plus 3 is equals to a into x minus 3 plus b into x plus 1. X plus 1 is a linear factor. So if you equate it to 0, x equals to minus 1. Minus 1 is the root. So root has to satisfy the equation. So put x is equals to minus 1. So 2 into minus 1, minus 2 plus 3, 1. So a into minus 1 minus 3, minus 4. So this is a is equals to minus 1 by 4. Put x is equals to x minus 3 is the linear factor. Equate it to 0, x equals to 3. 3 is the root or solution, and root has to satisfy the equation. So put x is equals to 3 here. 2 3s are 6. 6 plus 3 9 is equals to 3 minus 3 0. So b into 3 plus 1 is 4. So from this b is equals to 9 by 4. Therefore 2x plus 3 by x plus 1 into x minus 3 is equals to a is minus 1 by 4 by x plus 1 plus b is 9 by 4 by x minus 3. Therefore the answer is minus 1 by 4 into x plus 1. A by b by c, a by bc, 4 into x plus 1 plus 9 by 4 into x minus 3. The second question, 5x plus 6 by 2 plus x into 1 minus x. So the denominator contains two non-repeated linear factors. So therefore two constants are going to be used. So a by 2 plus x plus b by 1 minus x. So 5x plus 6 by 2 plus x into 1 minus x is equals to LCM is 2 plus x into 1 minus x. So a into 1 minus x plus b into 2 plus x. So here 2 plus x and 1 minus x are the linear factors. So x equals to minus 2, x equals to 1 are the roots. Put x equals to 1. Here 5x plus 6 by 5x plus 6, this and this are gets cancelled. So a into 1 minus x, b into 2 plus x. So put x is equals to 1. 5 ones are 5 plus 6 11. A into 1 minus 1 0. B into 2 plus 1 is 3. From this b is equals to 11 by 3. Put that x is equals to minus 2. Substitute here 5 into minus 2. Minus 10 plus 6 minus 4 is equals to a into 1 minus of minus 2. 1 plus 2 which is 3. So a is equals to minus 4 by 3. Therefore 5x plus 6 by 2 plus x into 1 minus x is equals to a is equals to minus 4 by 3 into 2 plus x plus 11 by 3 into 1 minus x. 3x plus 7 by x square minus 3x plus 2. First of all, the denominator is not containing the linear factors. Linear factors is of the form ax plus b, px plus q, cx plus d, etc. So, for that purpose, let us factorize this. So, 1 2s are 2, 2 1s are 2, minus 2 minus 1 is minus 3. So, this is x square minus x minus 2x plus 2. X if you take common x minus 1, minus 2 if you take common x minus 1. So, this is x minus 1 if you take common x minus 1 into x minus 2. Therefore, the given proper fraction x square minus 3x plus 2 can be rewritten as 3x plus 7 by x minus 1 into x minus 2. Now the denominator contains two non-repeated linear factors. So, a by x minus 1 plus b by x minus 2. So, this is equals to 3x plus 7 equals to a into x minus 2 plus b into x minus 1, taking LCM and cancelling the denominators on both the sides, we are getting this. So, x minus 1, x minus 2 are the two linear factors, x equals to 1, x equals to 2 are the roots. Put x equals to 1. Substitute 3 1s are 3 plus 7 10. So 1 minus 2 is minus 1 into a minus a. So a is equals to minus 10. So put x is equals to 2. 3 2s are 6. 6 plus 7 13 is equals to 2 minus 2 0. 2 minus 1 is 1. 1 into b. So b is equals to 13. Therefore, 3x plus 7 by x square minus 3x plus 2 is equals to a minus 10 by x minus 1 plus b 13 by x minus 2. X plus 4 by x square minus 4 into x plus 1. First of all, this is a fraction. To be more specific, in the proper fraction, because x power 1, degree 1, here degree 3. So degree of f of x is less than degree of g of x. And x square minus 4, this is not a linear factor. This is a quadratic factor, right? So x square minus 4 is written as x plus 2 into x minus 2. So this is x plus 4 by, this is x minus 2 into x plus 2 into x plus 1. So here, three non-repeated linear factors are there. Therefore, a, b, c are the three constants which we are going to use here. So, this is a by x minus 2, b by x plus 2, c by x plus 1. So, if you rearrange the order also, it's not a problem. So, what I mean is a by x plus 1 plus b by x plus 2 plus c by x minus 2, if you take and solve, then also you will get the same answer. So, this is equals to x plus 4 is equals to by x minus 2 into x plus 2 into x plus 1 is equals to, the LCM here is x minus 2 into x plus 2 into x plus 1. So x minus 2, x plus 2, x plus 1 by x minus 2. This gets cancelled. So a into this is, these are the two we are getting. This is just LCM I am finding. So a into x plus 2 into x plus 1 plus b into x minus 2 into, this is x minus 2 into x plus 2 into x plus 1 by x plus 2. So we will get b into x minus 2 into x plus 1. So b into x minus 2 into x plus 1 plus c into x plus 1 gets cancelled. We will get x minus 2 into x plus 2. That is x square minus 4. So this and this gets cancelled on both the sides. So x plus 4 is equals to a into x plus 1 into x plus 2 plus b into x minus 2 into x plus 1 plus c into x square minus 4. Put x is equals to, so here is equals to 2, minus 1. So minus 1, minus 2 and 2 we are going to use. Put x equals to minus 1. Substitute here. Minus 1 plus 4, 3. So a into minus 1 plus 1, 0 into something, this is all 0. Here also if you substitute minus 1 plus 1, 0 into something, 0. So we will be left with the c only. So c into x square minus 1 whole square is plus 1. 1 minus 4 is minus 3. So this is c is equals to minus 1. 3 ones are 3. So put x is equals to minus 2. Substitute. Minus 2 plus 4, 2. So minus 2 plus 2, 0 into something, 0. So next here, minus 2 whole square, 2 square, 4, 4 minus 4, 0. So we will be left with b only. So b into x minus 2. So minus 2 minus 2, minus 4, minus 2 plus 1, minus 1. So this is 2 times. Therefore, we'll get b is equals to 1 by 2. Likewise, put x is equals to 2. If you substitute here, 2 plus 4, 6 is equals to 2 plus 2, 4. So this is a into 2 plus 1, 3. 2 plus 2 is 4. So the 2, if you substitute here, 2 minus 2, 0 into something, 0. 2 square, 4 minus 4, 0. So this is 3 2's. So a is equals to 2 2's. So a is equals to 1 by 2. Therefore, x plus 4 by x square minus 4 into x plus 1 is equals to, the value of a is 1 by 2 by x minus 2. So 1 by 2 into x minus 2 plus b value is again 1 by 2 into x plus 2. The value of c is minus 1. So minus 1 by x plus 1. 2x square plus 2x plus 1 by x cube plus x square. So this is 2x square plus 2x plus 1 by, take x square as a common. Then we'll get x plus 1. So here this is type 2 because x square can be written as x into x. So this is a repeated linear factor. For repeated linear factor, we will write a by x. Since it is repeated twice, so again b by x square plus c by x plus 1. This is equals to 2x square plus 2x plus 1 by x cube plus x square is equals to. So the LCM here is x into x square into x plus 1. So this is x cube plus x square only. So this is a into, this is x square into x plus 1 by x. X gets cancelled. So a into x plus 1 plus b into x square into x plus 1 by x square. X square gets cancelled. X plus 1 we are left with here. Plus c into, this is x square into x plus 1 by x plus 1. X plus 1 gets cancelled. We are left with x square here. So this on both the sides gets cancelled. 2x square plus 2x plus 1 is equals to a into x plus 1 plus b into x plus 1 plus cx square. Here x is a linear factor, so x equals to 0 is the root, x equals to minus 1 is also the root, x equals to 0 and minus 1 we will use and will proceed. So 2 of ABC we are going to get. The third, to obtain the third constant, let us use the comparing the coefficients method. So let us do this. Put x equals to 0, substitute 2 into 0, 2 into 0, therefore 1 we are left with here. So 0 into something 0. So c into 0, 0. So b into x plus 1, 0 plus 1 is 1. So b is equals to 1. Likewise, put x is equals to minus 1. Minus 1 whole square is 1. 1 2s are 2. 2 into minus 1 minus 2 plus 1. So a into minus 1 into minus 1 plus 1. This is 0. This is 0. So minus 1 plus 1. This is also 0. C into minus 1 whole square is plus 1. So this and this gets cancelled. We left with c is equals to 1. Now we are not left with any linear factors because x and x plus 1 are the two linear factors. Of course, x has been repeated twice. Therefore, we cannot use more than x equals to 0. Therefore, comparing the coefficients. Comparing the coefficient of x square on both sides. We can compare quotient of x or constant also. So x square quotient is here 2. Here if you expand this, a into x square quotient is a here. So here x square quotient is c. So 2 is equals to the value of a we don't know plus c value is 1. So 2 minus 1 is 1. So a is equals to 1. Therefore, given 2x square plus 2x plus 1 by x cube plus x square is equals to the value of a is 1 by x plus value of b is 1 by x square plus c value is again 1 by x plus 1. This time 2x plus 3 by x minus 1 whole cube. This is a proper fraction because x power 1 here x cube. So degree of the numerator is 1, degree of denominator is 3. So degree of f of x is less than degree of g of x. So the denominator contains repeated linear factors type 2. So for every repeated linear factor there corresponds to a partial fraction of the form a by ax plus b, b by ax plus b whole square, c by ax plus b whole cube, etc. So here a by x minus 1 plus b by x minus 1 whole square plus c by x minus 1 whole cube. So here LCM is x minus 1 whole cube by x minus 1 whole square into a. So a into x minus 1 whole square plus x minus 1 whole cube by x minus 1 whole square, x minus 1 times into b. So b into x minus 1 plus x minus 1 whole cube by x minus 1 whole cube gets cancelled. We are left with c here. This is 2x plus 3 by x minus 1 whole cube. So cancelled. So put x is equals to, here x minus 1 is the only linear factor. So equated to 0, x equals to 1 we will use. 2 1s are 2, 2 plus 3 5. So 1 minus 1 0, 1 minus 1 0. So c. So directly c is equals to 5 we get. Now to obtain the remaining constants, let us compare the quotients on both the sides. Comparing coefficient of x square on both sides. So here we don't have x square quotient here. We only have x and the constant here. Therefore, x square quotient is 0. So if you expand this, a into x square minus 2x plus 1. So x square quotient is a here. We don't require x and the constant since we are comparing the quotient of x square only. Now, here b into x minus 1. X and constant we have here. Here constant. Therefore, a equals to 0. Comparing constants on both sides. Here the constant is 3. Here the constant is x square minus 2x plus 1. So 1 into a. So b into minus 1 minus b. B into minus 1. Constant is minus b plus c. So 3 is equals to, the value of a is 0. The value of b, which we don't know, c value is 5. So this is 3, b is equals to 5 minus 3 is 2. Therefore, 2x plus 3 by x minus 1 whole cube is equals to, the value of a is 0, 0 by x minus 1, 0. B value is 2 by x minus 1 whole square. C value is 5 by x minus 1 whole cube. So we have the another alternative method also to solve this. And this method is particularly useful when the denominator contains a only repeated linear factor. So yes, here the only repeated linear factor we have. What I mean to say is x minus 1 whole cube into x minus 2, something like that we don't have. Only repeated linear factor we have. For which let x minus 1 equals to y we will take. So from this x equals to y plus 1. So 2 into x can be replaced as y plus 1 plus 3 by x minus 1 is how much? Y. X minus 1 is y whole cube. So this is equals to 2y plus 2 plus 3 by y cube. 2 plus 3 is 5. So 5 plus 2y by y cube. So 5 by y cube plus 2y by y cube 2 times. So 5 by, replace y by x minus 1. So x minus 1 whole cube plus 2 by x minus 1 whole square. So you can compare this also. So this is the alternative method, and this method is particularly useful when the denominator contains the only repeated linear factor.